All right, there are still some people coming in, but please have a seat. We'll get started slowly. Um, Recently, I was thinking about my career in tech, and I was trying to think whether IoT was a thing that I should investigate time in. I mean, there's so many things that we need to learn, right? In our that's why we're here. That's why so many of us. I don't know. Is it following me? Okay. So yeah, that's why we're here. We're here to learn about all those different technologies, and IoT was one of those technologies that I was wondering, should I actually take the time to learn it? And so I started doing a little bit of research, as we all do, right? And I started looking at some charts, information that you can find it's freely available. There's a lot of research that are saying things like there are currently about 50 billion connected devices working in the world. And it is estimated to go up to almost 80 billion by 2025, which is dangerously close. So, and I was like, 50 billion devices? That doesn't make any sense. That would mean 6 devices per person on the planet. I was like, there's no way that is true. So I started thinking, and I started thinking, look, what do I have at home that is connected to the internet? So there's 2 of us in the house, me and my partner, and we each have our laptop. So that's 4 devices that are connected to the internet, and then we each have our cell phones, so that's another 2 devices, and we each have our tablets, so that's another 2 devices. Now, some people would argue that those are not IoT devices; they're just devices connected to the internet. Fair enough. So what else do I have? Well, my thermostat. My thermostat is connected to the internet because, well, that's kind of convenient. I've got my smoke detectors that are connected to the internet. I get to travel a lot for work, so I love to know that, if there's a fire at my place, I'll know. Not that I can do anything about it, but I'll know. What else? I have my TVs connected to the internet. It's a smart TV. My car. Recently, I started my car with my phone. I was like, wait a minute, my car is connected to the internet. Got a couple of smart bulbs. I think a lot of people have those around. Connected plugs, very useful for Christmas lights and different things. I put them on a schedule. Connected speakers, I got the Sonos, they're amazing sound, connected to the internet. A couple of cameras around the house. I recently did some DIY renovations around the house. So I had a couple of accidents, so I've added some water leak sensors. Some home assistants. Most of us have those nowadays because we don't really care about privacy anymore. Door locks, because I don't really care about security anymore. So one in front, one in the back. At that point, might as well put the garage door. What else? My air fryer. Now, so I have to go to my air fryer, put the things in, and then pull out my phone and actually start it. Very convenient. What else? A barbecue. My barbecue is also connected to the internet, because why not? I redid my bathroom, so I added heated floors. Those are controllable by internet or by Wi-Fi. While I was at it, I installed an Iot Shower. That's really cool. The good thing about it is that if the smoke detectors go on, I can actually start the shower, so I'll save my bathroom. My vacuum, got one of those Roombas. Recently, a little bit concerned about my weight. I got a scale, which is connected to the internet. Blood pressure monitor. I'm into healthy stuff nowadays. Oh, I got cats at home, so I like to know how they're doing. So I have my cat litter is connected to the internet. My toothbrush, just don't buy a connected toothbrush. It's not worth it. And then finally, I've got a couple of fermenters, but we'll get back to that in a couple of minutes. So IoT devices, if everybody's like me, yes, you should probably care about those, because at some point in your career, you'll have to deal with IoT devices in some shape or form. So before I get on with my talk, let me introduce myself. So hi, my name is Joel. I work as a developer advocate at MongoDB. If you haven't seen us already, come and meet us at our booth. We're right downstairs. We've got some cool swag. Also, I'll be there to answer any questions you might have, whether it's about beer or MongoDB. If you ever want to get in touch with me, Twitter is always a great way. I'm often there on Twitter. I always answer any message that you might have. So that's Joel with 2 underscores Lord. It's like the worst Twitter handle ever. I've realized 2 years later that Joel Lord in one word was taken by myself with another email address. But it is what it is. All right, so what are we going to talk about today? We're going to talk about JavaScript, IoT, and beer brewing, as the title kind of hints. I'll talk a little bit, and that kind of comes after COVID. After spending 2 years, alone in my house, watching videos like 10 minutes max videos and watching them at 1.5 speed. Um, I've started to think that 45 minutes is a bit of a long talk. I find it hard to focus for 45 minutes. So I'll kind of split my talk in 3 parts. So we'll talk about IoT, JavaScript, how we can use those together. We'll take a small break. We'll talk about beer brewing basics. And then we'll talk about sensors and data and a dash of Java. Of course, so you don't hate me too much. Before I get started, I know this is a Java conference, so I just want to make sure everybody's familiar with JavaScript, everybody knows what it is. So JavaScript is a subset of Java, as the name implies. Of course, it's kind of very similar. The syntax is almost the same. The big difference is that it doesn't have types, because who needs strong typing anyways, right? I'm surprised nobody booed me already. That's all good. All right, I'm sure you all know what JavaScript is. And one of the reasons that I wanted to talk about JavaScript here, even though it's mostly a Java conference, but when it comes to programming microcontrollers, you can actually use JavaScript, and that's a very convenient way to get started as a hobbyist into JavaScript. So I'll talk a little bit about that today. I love using JavaScript in general. I find that it's a convenient language to put together some stuff very quickly. This is a demo from a conference I did a couple of years ago where what you see right there is a tiny robot that I've built on Arduino. And you can see in the background there's kind of a skeleton that you'll see show up in a couple of seconds. And that was a gesture detection library that I've built in JavaScript. Like it's an overnight project, and I was able to control my robot using that library. So I like the fact that you can kind of use it everywhere. So I was able to use it all the way along the stack, so in front end, back end, database, and as well as the IoT devices. So in order to run JavaScript on IoT devices, there's a couple of ways to do it, and it will really depend on the device that you want to use. If you've ever looked into programming your own IoT devices, you've probably stumbled on the Arduino, just an open source board, a great product. I wouldn't say the problem is, but you have to use C to program it. I'm not very familiar with C. So it was relatively hard for me to kind of get a grasp and understand how to really program them. So I decided to use JavaScript, and it is possible to use it, but the way you'll use JavaScript on an Arduino device is that you'll flash a firmware on it, and basically you'll be able to communicate from another machine using Node.js and communicating through a standard format or a standard protocol, and then the Arduino will do whatever you tell it to do. So that works, but you kind of still need that second machine next to it. So the 2 devices that I'll really be talking about today are the Espruino and the Raspberry Pi. The Espruino looks a little bit like this. I have one. I'll show you in a second. The Espruino Wi-Fi is a tiny USB Wi-Fi enabled microcontroller that can be programmed in JavaScript. Just plug it into your computer and get started in seconds with the web IDE. I love the marketing spiels. So it's this tiny little device. Let me see if I have it here. So it looks a little bit like this. Yeah. So it looks a little bit like this. And you can see that there's a LED built in. There's also, right here, you can see that there's an antenna, so that's for the Wi-Fi. So it has Wi-Fi built in. It's very convenient to build small projects. So those are relatively cheap. The IDE to program them looks a little bit like this. So this is actually running into an iframe. So basically, it's just a web page. You go to the web page, connect your Espruino into your USB port, and you're able to flash your code to it. So I have it running here. So if I go and try to connect to my device, I'll try to connect to a web serial. This is the part where I get really nervous because it never works. Unable to retrieve board information. Come on! All right, let's try it again. Let's try to turn it off and on again. Now you see me sweating. All right, one last time. If it doesn't work, it doesn't matter. Something's happening. more error messages. All right, but this is the code that you would use basically to flash one of those devices. So as you can see, it's just your regular JavaScript code, and it is interpreted on the chipset. So it will run that JavaScript code. So basically, what this one does is that every 500 milliseconds, it'll just take the LED. So there's a couple of built-in objects, such as LED1, which is the port for the LED that is already there, and then it will just write to it, and it'll turn it on or off, and it blinks. So if you're new to the IoT world, the first hello world that you'll want to build is a blinking LED. It is very boring when you try to show it, which is why it doesn't really matter. But it is very exciting when you get it to work for the first time. So that's the first thing that you'll want to do. Once you get into something like that, wow, nothing is cooperating right now. You can go into something a little bit more complex and have a code that would look a little bit more like this. So this one, basically what it does is that it uses this little sensor that is connected to it. If I switch back again, there's a little dongle right here. And it will just take the temperature and humidity levels in the room. That code, basically what it will do is that it will connect to the Wi-Fi using the built-in libraries, get the temperature from that sensor, and then send the data to the web to an HTTP endpoint. I'll get back to the HTTP endpoint in a couple of minutes, and then it just outputs, console logs the content. So basically, just take those measurements and send them to the cloud. So that's the only thing that it does over and over. It really bugs me that it doesn't work. Unplug it. That's the thing. That'll work. Thank you. Who said that? You'll get a pair of socks when you drop by our booth. Like everybody does, anyways. Thank you. All right. So as I said, it is very exciting. So I now have a blinking LED. Totally worth the wait, right? Yeah. Okay. So if I take the code that I had here, actually, might as well try it now. That's really, you won't copy and paste now? Copy, paste, boom. And all right, let's try to flash that. What line? Line 13. There you go. This is going to be so much fun. All right. There you go. All right, so slowly but surely, it's kind of flashing. You'll see it blink slowly. Eventually, I'm using those LEDs as a way to get feedback from the device. Eventually, yeah, it blinks blue, so it's connected. And then the green means that it's actually sending a request to the server, and then I get the response from the server. Whew, that worked. Okay. Getting very hot here. so thank you for your support. I appreciate it. Okay, where were we? I had some slides somewhere. There you go. All right, so that's what the Espruino does. It's usually much easier than that. It's less stressful when you do it in your own living room. So basically that's the code. So as I said, if you've ever done JavaScript, you should be familiar with this syntax. So basically, I'm just toggling the status and then writing that to the LED, and it blinks. All right. So the other way that you can program microcontrollers is through a Raspberry Pi. I do have one somewhere. But basically, they look like this. The Raspberry Pi is a little bit more complex. It's a tiny dual desktop computer and robot brain, smart home hub, media center, network, AI core, factory controller, and much more. All right, so what does that mean? Well, basically, it's a computer. That's the only thing that it does. But the big difference between this one and, well, your laptop is that it has a bunch of I/O pins on top of it. So you can connect sensors, and you can do all kinds of cool stuff with that. If you want to get started with the Raspberry Pi, I highly recommend using Johnny 5. So Johnny 5 is a JavaScript library. They've got absolutely the most amazing documentation ever. If you look at their documentation, even if you're not using Johnny 5, actually, their documentation also includes all the schematics for any sort of sensor that you'll try to add to your IoT device. So just look for a type of sensor. So as I said, this one is called a DHT11. So just look for DHT11 in Johnny 5 documentation. You'll find it, and you'll see all the schematics on how to plug it. So you don't have to be worried about putting resistors and burning your sensors. Then install Raspberry IO, and then you can just instantiate a new board, new 5.board, and then when the board is ready, so it's an event-based library. Oh yes, I know you all love callbacks, right? So there's a callback, and then you can do stuff like blinking that LED. So instantiate a new LED, and then just use the blink method, and it will blink that method. You can also use Python with those. There's, well, pretty much every language you can use on the Raspberry Pi. I just want to stick with JavaScript for this example. All right, so which one should you use? Should you use an Espruino? Should you use a Raspberry Pi? Well, it depends, right? So it really depends on your use case. The Espruino is a tiny microcontroller, so its only purpose is to do something very, very quickly and just send the data as fast as it can. It's not meant to process any sort of data. So in this case, for example, where it just reads the temperature and just sends it, it's a very dumb device. That's perfect case for the Espruino. They're tiny, they're cheap, and you just do a bunch of readings and just send that blindly to a database. On the other hand, if you want to build something more complex, if you want to have a bunch of automations with your sensors or actuators, say you want to connect some lights and you want to check when the sun goes down, then turn on the lights. And if you want to build something a little bit more complex where you need to integrate with other systems, other APIs, then the Raspberry Pi is probably a better choice because, again, it's a computer. All right, time for a little break. Let's talk about beer. It's usually the time where I crack open one, but I couldn't find one close. Let's talk about beer. So this whole talk was like an excuse for me to talk about one of my favorite hobbies, which is beer brewing. So here you are, all stuck to listen to me for a couple of minutes to talk about beer brewing. You must be 18 years old to listen to this presentation. This is a legal age in Quebec. I don't know, it's 16 here? Whatever, I'm pretty sure everybody's okay. One note, though, speaker is in no way encouraging the abuse of alcoholic beverage. I do believe that as in the tech industry, we kind of have a problem with alcohol a little bit. And I just wanted to make it clear that I love brewing, but I'm not encouraging the abuse of alcoholic beverage, and I think it's important to note. So what am I going to talk about now? I'm going to talk a little bit about beer. We'll talk about the definition, just to make sure everybody... We're in Belgium. Like I should assume that everybody knows, right? We'll talk about the ingredients. We'll talk a little bit about the process. Any home brewers in the room? Nice. Nice. Come and chat with me afterwards. I'll be more than happy to geek out on beer. We'll talk about the end product. So a little bit about me, eh? I'm based in Gatineau, Quebec, so I do speak French. What you might not know about me is that I'm master brewer and co-founder of Brain Brew Canada. Now, don't look for our products in store. That's pretty much our setup. Actually, that's not true. This is our 20-liter setup for experimental batches. This is actually our setup. This is about, we do 20 gallons, so 80 liters. And sometimes we'll do 2 batches. So 80 liters is 325 centiliters bottles, and then we'll do 2 batches. As I said, I love to brew. I have a lot of friends that like to drink as well. But if you're ever in the Ottawa area, feel free to drop by. This is my beer fridge, so I always have a couple there that are plugged. So let's talk about the history of beer, just in case you didn't know what it is. First of all, what is beer? What's the definition? Technically, by Canadian law, most Belgian beer are not actually beer. So a beverage elaborated from cereal grain, the fermentation process involved in brewing produces alcohol between 4.1 and 5.5% of alcohol by volume. Stella Artois would fit. Less than that is a light beer, and more than that is a strong beer. So that's the only difference. All right, so a little bit about the history, where it all started. So there's a lot of archaeological research that has been done on the topic. I'm not the only one that enjoys the topic. They've actually found some residues of some sort of a beer that dates back 11,000 BC. And even found some pottery, or pre-pottery Neolithic, some evidence that it was actually produced 8,500 BC. So it wasn't an accident, it was actually produced by humans 8,500 BC. The barley started to be used as the first primary ingredient, which is the main ingredient that we use nowadays for brewing. That was about 3,500 BC. And that brings us to 2016, which was the foundation of Brain Brew. Nothing happened in Belgium in the meantime. All right, let's talk about the ingredients. So what do you need to make beer, right? Everybody knows there's 4 ingredients. First one is water. So you need some water. 95% of the, more like 90% in Belgian beer of the end product is water. The pH should be somewhat balanced. You want a little bit of acidity in it, so 5.2 between 5.6. Tap water is usually perfectly fine. That's what I use at home. Then you need some grains. Grains are very important. The malted grains, so it's a grain that is first germinated and then they dry it out. And then they roast it at different temperatures, and those different temperatures will produce different colors for the final product, right? So if you have like a porter or stout, it's very dark. So those are grains that were roasted at higher temperature, and it will produce a beer that is much darker. And then the starches from those grains will become the fermentable sugars, which is what we want in the end. So I talked about the color of the grains. When we look at a porter, we think of a very dark beer, right? So this is actually what a porter grain bill looks like. So this is about the amount of very dark roasted grains that you need, because we tend to think that it's like all very dark grains, and that would be way too sweet. So it's something like this. Just as an example, my recipe for a porter is about 76% base grain. So that's just your regular barley, a little bit of wheat. Then we add a little bit of crystal 75, so slightly roasted grains, and then the chocolate malt, which is nothing to do with chocolate, it's just a brand name. But those are speckles of black that you see in the picture there. And then carapils, which has nothing to do with the beer, carapils, just so we're clear. It's just a brand of grains, again. It helps with the foam on the beer. If you compare that to my IPA recipe, yes, I'm North American, so I drink a lot of IPAs. 88% base grain, a little bit of crystal just to color a bit, and then that carapils that comes again. So those are kind of the differences in the beer. So as you can see, it's mostly just that barley, slightly roasted barley that you have in most recipes. This is how much they are roasted. So when I said crystal 40 is somewhere at the bottom right. 75 is almost straight down, so you can kind of see the scale of colors that you have. Next, we have hops. Hops are very important, especially in modern North American beers. It's a fairly recent addition to the process. So it dates back 122 AD. It is responsible for the beer flavoring. Beer by itself, because it's made out of sugar, basically, it's very, very sweet. Like if you taste, when I'm preparing the beer before there's alcohol in it, some of my friends will come over with their kids and they just love drinking it because it's very, very, very sweet. So we add a little bit of hops to contribute a little bit to the bitterness, and it kind of cuts that sweetness a little bit, and it makes it more, well, it makes it better. So it contributes to the bitterness. There's different flavors and aroma profiles. So Chinook is very, very popular in Canada. You see it at the left, like it's very, very piney, so it'll give you a very specific taste. Citra, very popular in the US. Not sure what they use here, but those are mostly North American hops anyways. Finally, you've got the yeast. Yeast is my favorite ingredient. It's where the magic happens. It's the fun ingredient. It influences the final character, the flavor. It's all about the subtleties in your beer. And the fun thing about it is that you can either cultivate it, just like I'm doing right there, or you can actually just find it in the nature. So I've actually brewed batches of beer where I just put the kettle outside, wait a couple of weeks, and there's just yeast that magically appears in it, and it'll just make beer. So the process. Talk about the process. So this is kind of my setup. I've showed it to you already. So you've got 3 kettles. We've got a hot liquor tank, a mash tun, and a boil kettle. So the first step, you'll want to make sure that you've got some hot water into your mash tun. Put it at, we've got a weird relationship with a metric system in Canada where some of the things are in metric and some are in the imperial system. So 152 Fahrenheit, about 60 minutes, and that will extract all of these sugars or all the starches. And you recirculate that. So you actually filter out your wort using the grains that are there. And then you boil, normally about 60 minutes. And that's where you'll put in your hops. So the earlier you'll put them in, the bitter it will be. A little bit like when you make a tea, right? If you have very hot water, when you drop in your pouch of tea, it'll be very bitter, especially if you leave it there long. But if you just put it when the water's a little bit less hot, it won't be as bitter. And then you need to chill it as quick as you can. So that is done with cold water. This is actually a plate chiller, so you send your wort in one direction, the water in the other direction, so it will just cool it down. You can also use a copper coil such as this one, or you can just brew your beer the Canadian way, and it'll eventually chill. Then we've got the fermentation process. Fermentation is magical. Just like everybody else during COVID, I started making my own sourdough bread. And it's exactly the same process, which is why I love this image. So you put in some yeast. In this case, it's wild yeast, so you just leave some flour on the counter. Eventually, it starts fermenting. So yeast and sugar will create ethanol and CO2. So that's really magic. I know you've got those little living things, and you can see like it really moves like that. Sometimes it's even more than that. The one on your right actually exploded. There's so much activity that comes from that process. You've got those little living creatures just, swimming into your wort and eating all of that sugar and producing alcohol and farting in your beer, and it's just you have this end product, which is all the magic. In order to calculate the difference, or the alcohol that you have at the end, you need to calculate the difference in sugar at the beginning of the process and the end of the process. So the fermentable sugars will be transformed into alcohol. So that's how you'll know how much alcohol you have in your beer. Oh yeah, my cats love that part. The wort, again, is very sweet, so they love it. So water density, that's a fun experiment that you can do with kids if you have kids at home. So the more sugar you have in water, the denser it will be. So you can take colored water, and then you add a lot of sugar in the yellow one, and then a little bit less in the green one, and a little bit less in the red. And you'll be able to make those float on top of each other. That's because of water density, right? So the more sugar, the denser the water will be. And you'll measure the amount, or you'll be able to measure that density using a tool such as this one, a refractometer, which is also used for pastry. You can use also an accelerometer. Oh, we'll come back to that. Finally, we keg the final product. We've got everything into the beer, and we've got our end product, which looks a little bit like this, and that's what it is. Santé. All right. Okay, where the hell is this guy going with this? Bear with me. This slide. Let's come back to that one. All right, so this is it's an open source project, actually, not by myself. I've tweaked it a little bit for my purposes, but this is called the Ice Spindle. It's actually a German project, and it uses an accelerometer to detect the angle of the device. So there's a little weight on it, and the denser the water, the more it will be at a horizontal position, and the less sugar that you have, the more vertical it will become. So you can actually measure the amount of sugar inside of your fermenter using that device. There's also a thermometer in it, so we can know the temperature of your fermenters, and you can kind of control different aspects to it. So it is built on an ESP8266, which is the exact same chipset as this tiny little Espruino that I showed you earlier. I usually bring some with me, but they're actually in use. So the accelerometer is there, used on the acceleration towards the ground, aka gravity. You can actually measure the angle, and using that, you'll be able to calculate, with a little bit of math, you'll be able to calculate the amount of sugar. So basically, again, very dumb device. It'll just do that reading. It'll check what's the angle, what's the temperature, and just send that raw data into an HTTPS endpoint. But then what? Well, that's the whole thing with IoT devices. So IoT devices are kind of, well, we call them smart devices. Most of the time, they're very, very dumb devices. But it's all about the data that you get out of it. So we got those billions of devices. They just produce all of that data. And of course, a lot of those IoT devices are used more in an industrial kind of context. I'll be talking mostly about my fermenters right here, but it kind of gives you a simplification of the processes. So basically, you always have your devices. They're connected to sensors and actuators. And then they connect to some sort of internet gateway. It could be done through various protocols. Zigbee, Z-Wave are very popular for home consumer products. And I can never remember which one. One of them is a mesh, so it's also used for industrial context. So the more devices you have, the more reliable your whole ecosystem becomes. Then you send that data to the edge of the cloud. You want to do some processing. So if you have things like sensors on an industrial machine and you can detect some sort of shaking at some point, then you can immediately react right before it gets sent to the cloud. But eventually, you'll send all of your data to the cloud for later on processing and analysis and so on. So this is what I have at home. I've got my 2 fermenters. They are connected directly on the Wi-Fi through my home router. And then they connect to Realm function, or Atlas Application Service function. We just changed the name. So they connect through that HTTPS endpoint. And then it is sent to the developer data platform. From there, I use an Atlas database to store the data, or a MongoDB database to store the data. I use charts for visualization. I use database triggers in order to actually send me a text message whenever my beer is ready, which is very useful. I send some data to my website as well, and then I use aggregation pipelines to perform some analytics. So let's look at those into a little bit more details. So the first part is the serverless functions. That's one of the things that I really enjoy about using Atlas. So MongoDB has a cloud offering. They have a free tier. All of this is running on the free tier, actually. So you should give it a try. So you've got all of those things that are a little bit outside of the database, but are connected to your database. So database by itself, well, that's nice, but you still need to access it. You still need to write and read from it. So you can use serverless functions to do that. This is what the UI looks like. So basically, you'll just go into your project. You can create a function, which is what I do right here. I'll just create a random function, so something that is not brewing related. You can set your authentication, set your security standards, and then you'll just go to your function editor. That one is actually only JavaScript. So you'll have to write your JavaScript here. In this case, I'm connecting directly to my MongoDB collection. So, and that's the nice thing about it. So you could technically use a AWS Lambda or an Azure function, but it's a little bit more complex, and you have to jump through some hoops to connect your MongoDB database. So this one is connected directly, very easy to use. Get your data that you receive. I just append a timestamp to it, and then I send all of that into a collection, and it's there available for me. Next up, I just create my endpoint. So I create an HTTPS endpoint, give it a route, I enable it, make sure that I put it as a get. Should be a get. I'll return some data as well. I'll specify the function that I want to be triggered whenever I hit that HTTPS endpoint. Deploy all of those changes. There it is. And then I can actually copy and paste that command, which is just a curl command, to hit that HTTPS endpoint. And you get the result at the end. So this one is actually inserting a new record inside my database, and I return all of the entries in the database. All right, next up I'm using a MongoDB database, of course, because they pay me to actually use a MongoDB database. So I'm using a time series collection in this case. Time series are very nice. They abstract away, in MongoDB, they abstract away all the fact that it's a time series collection. So you can access them and query them exactly the same way as a regular database, or as a regular collection. So this is how your database normally stores data, right? It'll just take any new entries. Whenever you add them, it just creates a new entry, and it just stores it right there. It doesn't really care about where it is, and it's kind of stored all over the place on your disk, and it uses all of the different blocks. So when you're ready to query your data, especially when it comes to IoT, you'll want all the data about a specific sensor, right? So the data is kind of all scattered all over the place. You've got all of those different items that you need to read, so it's not very performant when it comes to time series related data. When you're using a time series collection, you have something a little bit more like this. So the data is kind of more structured into, it creates those buckets, basically, of all the entries. And you can see at the bottom part that there's only one entry per bucket. So I'm having a lot less entries. It saves a lot of disk space. And when will come the time to query the data, because the data is all closely located together, it's much easier, much faster to query that data. It's also much easier and faster to perform window functions. So things like, oh, give me the average over the last 7 days, for example, which is something that we've seen a lot over the last 2 years. Right? So there's always those charts, like average over 7 days. So yeah, so when you query data, well, eventually it'll query data. Really? It goes on forever. Nice place for a break. There it is. All right. OK, so when you query data, we've got a single entry that you're actually querying, and then you're sending back. So much more efficient in the way that you handle data. The nice thing about it in MongoDB is that it is actually fully abstracted to you, so you don't have to configure anything. Just use a checkbox, say it's a time series, and it's actually used behind the scenes. When it comes to querying, I'm using an aggregation pipeline as well as a function. So basically, you've got all of your documents. This is actually from Compass, a GUI for MongoDB. You can filter all the data. You can find a single element. But if you need to build something a little bit more complex, you'll want to use an aggregation pipeline. So the aggregation pipeline look a little bit like this. So in this case, I'm just doing a match, finding all the entries that are valid, so not -1. I'm also looking at sorting all of those orders, or all of those entries by descending order of receive that, and then I just leave it to 1. So I'm only picking the latest entry that is a valid entry in this case. Because it was written in JavaScript and I didn't have types, well, it was saved as a string, so I need to convert that. Yay JavaScript. So I need to convert those temperatures from a string into an integer so I can actually send it back to my application to be used. So this is what I'm doing. So those aggregation pipelines, you can really perform a lot of operations, very complex operations on your data. And then I've got my final result. I've got a little bit too many fields, so I'll just use a projection in addition to that, just to restrict the amount of data that I'm sending only to the temperature and the humidity, and the integers, as well as the receive that date. All of that, I can just go export that as code. In this case, I'm actually exporting as a Node.js. If you were to export to Java, this is what you would get. So this is the actual pipeline in code. So I like to use Compass. I like to build my aggregation pipelines using it. And then I just export all of that to code, and I actually have the code and that I can use directly into my application. To query the data, this is actually what it would look like. So you would create, define your connection string, define a new client, then connect to your collection, and then just use an aggregate. Collection.aggregate, and then you pass it this object that I've just shown on previous slide. Then for each document, you can perform an operation. So in this case, I'm just printing them out. A very cool thing that you can do with that is that you can also watch for changes. So what I'm doing right here, too bad it doesn't fit on the screen, but basically I'm getting that collection, connecting to that collection, and I'll just read the .watch method on it. So I'll be able to watch for any new change, any new insert, any new edits, any new deletes, or any new, and that's it. So any change in my database or in my collection, I'll be able to listen to those changes and react based on it. So basically what I'm doing here is that, when it doesn't fail, I'm actually just reading, and whenever there's a new entry that comes into my database, it should actually do a push notification, and I should get the new value right here. Oh yeah, I made it much smaller. All right, finally, I'm using the triggers. Triggers are actually using chain streams behind the scenes. So it's also part of the application services. Cool little feature that you can use. What I'm using it for here is that I'm actually going into the Atlas UI. I'm saying, well, send an SMS whenever there's a change in my collection. I'll select my cluster. I'll select the database as well as the collection. And then I'll do whenever there's a new insert, just run the following function. So I'll just write my function whenever there's a new entry into my database. And then I can do different things like sending an SMS message. So you'll see here that I'm connecting to a Twilio service. Everything is configured already. And then whenever I receive a new document inside of my database, what I typically do, or what I normally do in my application, is that I'll check the value. And if I see that it's constant, it's been constant over the last few entries, I know that my beer is ready. So that's when I'll actually use the Twilio service. I'll connect to it and just send an SMS message from it so I can actually get notified, because that would be too much work to actually go to my fermenter and look if it's ready. So you can use those database triggers to do all kind of stuff like this. Someone at the booth asked me a question about triggers earlier today. So, and then finally, we've got charts. Charts are amazing. It's a great way to do visualization tool. Again, it's integrated directly into Atlas, which makes it easy. So you simply go to charts, and then you've got here, I already have those charts mapped out. So I'm cheating a bit, but you see that it's kind of a drag and drop interface, and I can design those diagrams as I want them. So this is actually data, but you can see that at the left of the diagram, there's a little bit of invalid data, so I can just change the settings, configure that, and then I'll have the actual values that I want to display into my chart. You can create dashboards that you can share publicly with some stakeholders or all kind of different things, and they will be live updated as soon as there is any change in your database. So this is our website, brainbrew.ca, if you're curious to take a look. If you go into the What's Brewing tab, you'll actually see what I have currently brewing in real time. So let's see what I have brewing. I've got two sensors, so they're plugged into different sensors. I've just did a double batch just before I left. So this is the actual value that you have in it. So the first one is our rumination rye. So it's a rye beer, it's a beer with a little bit of rye in it. Very good, very tasty. I actually kegged that one, so when I pulled it out and I left it on my desk, that's why it was completely flat. So that's that little thing that I should change. You can also see that I was doing that outside and it was 15 degrees when I did that. So You really see that chart right there in that fermentation process. So when it starts, it really gets a sudden drop, and that's where in the first 2 days, maybe it'll start and it will be very, very active, and that's when the fermenter that I've shown you earlier that it just popped out is so active. So you see that sudden drop, and then it kind of slows down very slowly, and it'll just even out. And once it's evened out, that means that the beer is ready. Another interesting thing, we barely see it here. That's unfortunate because, well, winter is coming, and it's getting colder and colder. And you can actually see that my house is getting colder and colder by the day with this one right here. So the green line is the temperature of the fermenters. But you see that there's a little peak right at the beginning, right when there's that fermentation process. So it actually produces a lot of heat. So that's how I'm trying to convince my partner that I should brew more, because it heats up the house during winter. You actually see it a lot more better here. And it's the same kind of curve that you see right here. This one was actually another batch that I did at the same time, so the Melancholia Milk Cocoa Stout. And it has a sudden drop, and it was a very, very active yeast, and it was very sudden, and that one actually popped and made a mess when it started the fermentation process. So those are things that I kind of knew what was going inside my fermenters. You can kind of see activity when the fermentation process starts, but without using those IoT devices and getting that data and actually visualizing all of that data, those are things that I would have probably never bothered to look into. The temperature peak was actually very interesting. I did not expect that at all. And then the fermentation and how fast it can happen was also a big surprise for me. So that was a very nice thing that I got out of building that IoT device. All right, so that was a lot. So just a quick recap. Hopefully, that was a nice session. It kind of gave you a little break. It was 2 technical sessions, so we took a little break in the middle. But we talked about IoT and JavaScript, how you can use JavaScript to program little microcontrollers, those little Espino devices, Raspberry Pis. If you want to look at one, I'll be at the booth in a couple of minutes. Beer brewing basics, hopefully. Well, hopefully I didn't insult the Belgians by showing them how to make beer, because I assume that it's part of your genes by now. And then you've got all of those sensors and what to do with that data once you've got all of that data, how to process all of it and make sense out of those, all of that information, which is really the fun part about using those IoT devices. So with that, thank you so much for attending. If you want more information, the slides for both of the presentations are available at this link. Or if you have any questions, just come and talk to me. I'll be at the booth for the rest of the day and tomorrow. Thank you very much.